Hey everybody, this is Johnny Hunkins at Popular Hot Rodding Magazine, and we're building a small block Ford today, but it's a very special small block Ford. It's a 454 cubic inch aluminum block, and we've got a Ford Motorsport Z351 alloy block and Eagle rotating assembly with the Armor ESP finish on it. And we're at this point putting the crank in and putting the rod caps on there, the main caps, I'm sorry. And that right there that you hear is the electronic torque wrench, right, Ron?
Yes, it is.
This is Ron Eschen of Outlaw Motorsports. This is his engine. And what are you torquing those main caps to?
Starting at 65. Preset, and then the final torque is 105.
Right on. So you're using a kind of a stair-stepped
Yes.
deal, going up a little at a time. And what we're getting ready to put in over here, we've got the Eagle rods and the JE pistons over here that are specially made for our TFS CNC heads. And we got our ring packs there, all coming together today. We're going to try to get this whole short block built today for our story that's going to be in our April issue. Today we have a special guest with us, Mr. Steve Dulcich. He is the editor of Engine Masters magazine, and he also writes for us at Popular Hot Rodding because his specialty is engine building. Steve, tell us a little bit about this engine right here. What are some things that guys need to know if they're building a really big inch Windsor? What do we need to know here?
Well, the really nice thing about what we've got here is this Ford Motorsports aluminum block. It already has increased capacity. It's a 9.5 deck block, just like your standard 351 Windsor. Crankshaft. The stroke is increased quite a bit to 4.25 inch. It goes with a 4.125 bore, gives you around 454 cubic inches, which is big block size. A little bit of clearance notching for the rods, but the whole
Let's show
package
you what we
goes
got
together.
in here. Look at that.
Nothing too drastic, but necessary work nonetheless. Overall, it's going to be a nice, lightweight package with a big block torque and the packaging of a small block engine.
That thing's way down there. I guess when you've got a stroke this long in a small block, it's whoa, check it out. It's a lot of cubes. The more cubes you got, the more horsepower you have. We like horsepower, don't we, Ron?
Oh, yeah.
Don't we, Steve?
Sometimes.
I think this is one of those times.
Dimple right there. It has to line up with the wrist pin.
Now, Ron, that compression ring, what have you done to that? You've already done the file fit on that, right?
Yes.
And what measurement have you got? What kind of clearance have you got?
24 thousandths in gap.
24 thousandths in gap. And that's done on this machine over here, right, Steve? This thing right here is...
What you got there is a ring filing machine by Proform.
And that's what we've used on these. We've already actually done, or Ron has already done the file fit prior to our assembly today. We're using in our small block Ford the Moly Cleveite race bearings. Tell us a little about what we got going there, Steve.
Well, this is the HXN performance bearing from Moly Cleveite. The first thing you'll notice is it doesn't have the flash tin coating you'll find on a lot of stock passenger car replacement bearings. It's got a wider chamfer, so it'll clear the radius fillet and the crankshaft. And usually they're made with a little more taper. In other words, they get a little thinner on the parting line because that tends to pull in high RPM. And contrary to what most people think, the bearing isn't an even thickness all the way around. It's actually thickest at the base here, tapering slightly towards the corner so that these edges don't come in and scrape the oil off. It will result in a failed bearing at high RPM. So, nice piece.
Now, what a lot of people don't realize is that sometimes it's better to wait until order the bearings until after you have your rotating assembly, because you're going to want to mic all this stuff out, and sometimes you may want 1 under, 1 over, 10 under, just depending on what crank you're using, what rods you have. Ron is actually assembling this assembly here, and what's the trick to putting them in, Ron?
Really no trick. You just snap them in there. But there is an upper and lower half on the race bearings, so you got to do have to pay attention to which one goes where.
Right, and you also have a chamfered side and a non-chamfered side, depending on what the rod cheek where it meets the crankshaft. And the rod is specific to front and rear, so you have to pay attention to, obviously, the valve reliefs on the top of the piston, and also whether the rod is facing front or rear, because there'll be a chamfer on the side of the rod where it meets the crankshaft throw. Well, I really like these JE forged pistons that are going into this motor, Steve. Tell us a little bit about what's going on here.
Well, the first thing you'll notice, it's got a custom short dome, very small dome, to get the compression ratio where we want it. This is matched to the combustion chambers of the cylinder heads. Skirt coating reduces friction, helps a little bit with the oil control. You might notice that the pin groove in here is inboard somewhat from what you might be used to. That's because the piston pin's a little bit shorter, which of course makes it lighter weight. It's also this is a tool steel pin, and it's tapered walled. In other words, it gets thicker towards the center, and at both ends it's a little thinner. Again, a move to reduce weight. You'll also notice in here the skirt is relieved a little bit. That takes some material away where it's not quite necessary. Again, helping with piston and weight reduction.
We are using Eagle rotating assembly in this 454 small block Ford, and one of the things we have is a H-beam Eagle rod with their ESP armor and you can see it's really shiny. It's not chrome. It's not a plating. We don't really know what it is, do we, Steve?
Well,
But
a lot of people like to call it a coating. However, it's actually a process. And exactly what the process is proprietary to Eagle. You won't find that same process from any other manufacturer. Now, another nice thing about this particular rod, it's got an upgrade in the ARP bolts. These are the L19 material. It's extremely durable, very good for a high RPM, naturally aspirated engine like we've got right here. So, all in all, just a beautiful piece.
well, this coating, I'm still really curious about this coating. I guess the operative idea is that nothing sticks to it. It's just really enhances whatever lubrication you've got in the engine, whether it's for the purposes of friction or for oil shedding.
Well, you could probably pretty much drop this thing right into a big tub of glue and pull it out, and it'll look just about like it does right here.
It's got an interesting, when you pick the part up, when you touch it, it physically feels different than the uncoated version of the same part.
It's slick, you know, and that's all part of the idea here. When you've got a lot of oil bouncing around in the crankcase, a part like this is really slick, smooth, and it won't hold oil. It'll shed the oil, helping return to the pan where it can hopefully be picked up by the pump and do you some good, rather than adding windage losses and drag on the rotating parts.
Well, one thing's for sure, is an attractive process. I wish they could do the outside of the engine like that too. All of our pistons are in, and right now it's time to torque the rod bolts, which Ron has a torque wrench set on 79 pound-feet. What do we have for rod side clearance on this?
18.
18 thou. In this case, we're actually using Molly lube supplied by ARP, and that's where we get our 79 pound-foot measurement there. Now, if we were assembling this with straight 30 weight, the torque would be higher because actual clamping load varies depending on how much lubricity the assembly lube provides. One of the things I really like about this Ford Motorsport alloy block is how thick the pan rails are and the walls down there. Now, when you look at a cast iron production block, you just see lots of empty space in there. There's very thin walls in there, and it's actually recessed up in there. But it's solid straight through, and provides a lot of strength. And because it's an alloy block, it's actually quite a bit less weight than a cast iron block. So you get the strength without all the extra mass. Hey kids, this is something that's always really fun to do when you're building an engine, and that is see exactly how much torque resistance there is to turning it. That's a real good measure of the internal friction inside an engine, and will tell you kind of like how much extra power you can get from just building a really good rotating assembly. Ron, what is your torque gauge showing on this one?
It's showing
right around in the low 20s,
yeah.
20 pound-feet.
It depends on where we're at on the throw.
That's true. You had it earlier. It was 16, wasn't it?
Yeah. There's 16, 15.8, 14.
Not bad. Well, it's time to install our solid roller camshaft, which is from Comp Cams. We had this specially ground for us. The cam specs actually come from one of our favorite engine builders, Judson Massengill, at the School of Automotive Machinists. We went to him and got his recommendation for this cam. And Steve, tell us about the cam card. What's on it? Tell us a little bit why about what we got there.
Well, it looks like a pretty stout solid roller. When you look at the specifications here, we've got 268 degrees duration at 50 on the intake, 280 on the exhaust. Now those numbers for the average street cam. It might be the gross duration numbers, but we're talking about duration at 50 here.
Wow.
Lift, 768 intake, 748 exhaust. So notice the exhaust lobe is about 12 degrees longer in duration, yet slightly lower in lift. So we've got a milder lobe, easier on the exhaust side. Quick, fast snap it open on the intake.
Right on. We've got over 700-inch lift on tap here with this solid roller cam. And the reason is because we had a very specific goal with this engine. We wanted to break the 700 horsepower level with room to spare. Now, the reason why we can do that is right over here with this trick flow cylinder head. What is this head, Steve? And tell us how it's going to make us meet our goal.
Well, this is a 240cc CNC'd head. Now, what makes this come together with our camshaft to meet these goals is the phenomenal intake port. And looking at this flow chart, we've got a peak of 355 CFM at 800 lift. So, a cam that takes advantage and is able to tap into that high lift flow is going to help us get the most power that we can out of this head. Looking at the chamber side, we've got a very efficient looking heart-shaped chamber, a 2-100 intake valve, 1-600 exhaust, which is fairly standard. Now, flipping it around to the exhaust side, wow, look at that shape.
Wow.
It's almost a
high port.
Straight up shot.
It's like I think they lifted it 3/4 of an inch over stock.
Well, you know that's just got to flow tremendous amount.
Straight shot right there
of exhaust gas compared to any stock head.
So with the combination of 454 cubic inches, huge flowing cylinder heads that are CNC ported, and a really robust solid roller camshaft, you think we're going to be well on our way there to making our goal, Steve?
Well, what we did is we hedged our bets with some really good and well-selected parts that are going to complement each other in this engine combination.
This is Comp Cam's 8100 series ultimate timing set. It's designed to give the guy who's building a custom motor like this a lot of adjustability, both in degreeing the camshaft or, if necessary, to retard or advance the cam timing. We have a very large camshaft, obviously, in this motor, and when you sometimes build a very large custom motor like this, you sometimes get interference between the connecting rod and the cam lobe. So we're going to check that here in a minute and see if we're squared away. In dialing in our camshaft, you'll notice that we have this vice grip arrangement with our dial indicator. Obviously, we're not using a cast iron block, but an aluminum block, so we have to use this alternate apparatus to dial in the cam. And down here, we've already got it set to top dead center to calibrate that, and we're verifying where the peak lift is on the cam lobe. So are we where we're supposed to be on this run, according to our cam card?
Yep, well, we'll find out in a minute. So back it off and bring it to 50.
And what's our spec supposed to be?
72.
So where are we on the other side of the lobe, Ron? 152?
Yep, 72 divided by 2. We're exactly at 112.
All right.
Lucked out, but I want it at 108.
Yeah.
Yeah, Ron just moved the cam gear, and he's tightening back up the bolts and going to check to see where he is now.
Very much 48. 48 plus 68. 108.
All right, 108 degrees. Well, sometimes with really big stroker motors like this, you have some interference between the back of the shoulder of the connecting rod and the camshaft lobe. Now Ron has the engine turned over. If you look in that dental mirror right there, you can sort of see where that area of interference could possibly take place, and it looks like we're going to be just fine on this particular motor. Well, that concludes the assembly of the short block on our 454 cubic inch small block Ford. We're going to have the complete story for you in the April 2014 issue of Popular Hot Rodding Magazine.